This conference will now be recorded.
Good morning, everyone, and welcome to the Cloud Performance Engineering and DevOps demo session. Okay, so just to get started, this is something about me, like my IT experience. I am having like 13 plus of years of experience in IT, mostly into performance engineering and development, uh, Java, as well as I'm into Python development as well, and I'm a certified associate cloud professional, and I've also been involved into automation like PL SQL, shell scripting, and Selenium. And I'm currently working in an SRE. Yeah. So this will be the agenda of our discussion today. We'll start with a question, and then we'll go over software development and deployment evolution, and then finally we'll go into the course syllabus, and we'll set the expectations about this course, and then you can also post your questions, and then we'll look into what will I learn by end of this course, so that you have a clear idea what you're gonna learn and how we're gonna go about this course journey. And yeah, okay, so this is the question I intend to ask everyone here. We have this DevOps, microservices, containers, and cloud. So how many of you would agree that we as a performance engineers, we are expected to know this? Right? So you can ask this question to ourselves, and then we'll understand this. So let's put this in perspective and understand where this DevOps, microservices, containers, and cloud exactly fit in. Okay, so this comes to our software development and deployment evolution, right? So like back in like 1980s or back in 1990, we had these data centers, big data centers. If company wanted to deploy their own application, build their own application, they had to set up their own data center. Uh, but but again in around 2000s, we were able to host this. We had this option of hosting their application in some other data center. But nowadays we have shifted to this cloud, where we don't need to own any hardware, we don't need to set up any data center. We can simply leverage the hardware and the resources, and we can deploy our application. So that's been the software development and deployment evolution in this physical server space. Similarly, we had this physical servers in the data centers. We had this big physical servers. uh, back in 1980s, 1990, if any company wanted to deploy their application, right, they had to use the big physical server, and mostly it was unused, uh, so unutilized, I would say. So for that, then again, we entered the phase of virtualization, right, and we started to split this physical server. We started to split this physical server into VMs, and then we deployed our application components in these VMs, right? And by this was a very big revolution phase when this virtualization came, and we have a lot of virtualization software market players from VMware family. We have a lot of good softwares in the hypervisor, right? We installed hypervisor on top of that, and we did virtualization, and we were able to use the unutilized space in the physical servers. But again, the problem continued with after that. Again, the VMs was a very good move, but now we are in the phase from last 5 years. We are in the phase of containerization. You must have heard of this term, containerization, right? So again, in this, we are further splitting one VM into various containers, and we have container engine to do that. We have famous container engines like Docker or Rocket. Docker is the most popular container engine, and by doing this, we are so this all this move is to utilize the unutilized space, use the unutilized space which is there unused over the period of time. So now we have multiple containers in the same VM, and we can deploy our application in just one VM, and then we can scale up accordingly. So that's how the container fits in this picture. And now we have this microservices here. It is again as we all know, we had this monolithic way of development, right? When we started, so all our business logic were hosted in one particular server, like application server. We used to host all our business logic there. But we entered the phase of end-tier application, where now, like, back in 1980s, there was no concept of n tier, right? Everything was a one tier. But now we entered the phase of two tier and three tier. We talked about presentation layer, we talked about business layer, and we talked about database layer, right? But again, this monolithic way of development is being sorted out now in the form of microservices. Now we can split the same monolithic like architecture into microservices, into various sub applications. We'll go over this again in this course. We have few slides for that. And now enter the DevOps. We started with our waterfall model, right? We all know that we started with the waterfall model where all our software were developed at once, and then we tested it and deployed in production. It was a huge risk that time. If something went wrong in between, then gone the case. We would suffer in production. Now we entered into phase of agile, where the softwares were developed in the in phases. Phase 1, phase 2, phase 3, in the form of sprints, we call it, right? So it was a better move in agile. We are still in the agile phase, and we have also progressed, and we are in this DevOps phase, where everything is being done continuous development, continuous testing, continuous integration, continuous deployment. Everything is happening continuous. Like, basically, we are even split up this particular release into multiple releases, this particular phase or sprint into multiple releases, and we are able to automate this process. We'll talk about this DevOps. So that's what I meant to say when I said DevOps, microservices, containers, and cloud. And this is how these technologies or these terms fit in this IT world. And that's how the software has been developed and deployed over a period of time. And yeah, so let's go over this one by one in detail. DevOps, microservices, containers, and cloud. Okay, so talking to the DevOps, right? So we have this DevOps, like it's made of two words, as we all know, development and operations, right? And we have these are the phases here: plan, code. It starts with here: plan, code, build, test, release, deploy, operate, and monitor. So everything is continuous here in the form of infinity. You can see this. So basically, this is how the software is been developed now. And we have DevOps life cycle here. This plan and code refers to the continuous development phase. We have build and test. This refers to the continuous testing phase. And we have release here. That's called the continuous integration phase. That's where our Jenkins come into picture. We use this Jenkins for the continuous integration part. And we have this deploy now, deploy and operate. That's for the deployment. How we deploy our application, and that's the monitoring phase, continuous monitoring. And then we get the feedback. Then again, based on the feedback from the monitoring, we do incorporate that feedback into our development phase, and again we start with the process. And the software is, and everything is automated here. That's the beauty of DevOps. That once the developer checks in the code, suppose the code is being hosted in some GitHub repository, and the no audio. Hello, everyone can hear me?
I can hear you.
Okay, because I'm seeing few messages, no audio. Okay, so they need to fix their audio then. Yeah. Okay. So yeah, so this plan and code belongs to the development phase, continuous development phase. So based on the feedback from the monitoring, so we have the idea of shift left and shift right here. Shift left means getting engaged in the performance engineering process early in the development life cycle. So basically, we'll talk about this DevOps, how performance engineering fits in DevOps. That's one of the topics that we are covering in this particular course journey. So we'll talk about that in detail, the course details and course content. So this, just to give you an overview of the DevOps, that is how it is. So plan and code is the continuous development phase. We have build and test, that's the continuous testing phase. And yeah, I was talking about, so when the developer checks in the code, right? Suppose the code is hosted in the central repository somewhere in the GitHub. When the developer checks in the code, the pipe we're supposed to create the pipeline, CI/CD pipeline we call it. That's we're gonna cover. So CI/CD pipeline, that's what the developer will do. They will check in the code and everything will be automated, no manual intervention. So my code will be built automatically. It will be tested. So we have to provide. We're supposed to create jobs in Jenkins so that it get tested. Functional QA guys will do their part. They will create their own plugin. We will have our own jobs for the performance testing. If you're using Jmeter or LoadRunner, anything, so you can have your own job in the testing phase. And once that test is successful, it will be built. It will be now released. Continuous integration phase. It will your application, your code will be released into production and it will be deployed. Again, the same process goes on. So everything is automated here in DevOps. So basically, we are trying to reduce the time between the development and the deployment here. That was not the case with waterfall and agile. In agile, waterfall is a different way of developing, right? We developed all our software at once and then we pushed into production. Huge risk from the performance point of view. But we mitigated that risk in agile. But again, in agile, the main issue was that it was not smooth. The software deployment, development, and deployment were not that smooth. It took a lot of while. Basically, the environment, on the environment side, the software was developed, but not developed. The developer used a different environment. QA used a different. Now we have this technology called Docker, and we have images, so we can sort out that issue. We can have the same environment. The developer, whatever the environment developer is being used, they can put that in the image, and we can use the same environment for our QA work, for our testing work. And that is how it smoothens the process. It makes it is swiftly we can release our software in production. So that's the brief of our DevOps. Okay, we will go over and in detail in our regular sessions. I'm just going brief here. Okay, so let's talk about this microservices, right? And we have this monolithic way of development here, where you can see this my business logic here. This is my business layer. Is like all my I have taken this example of bookstore app, where suppose I have these functionalities: accounts, shipping, payments, or inventory. I can have any other functionality as well. So this is business layer I'm talking here. So here all my business logic, all my business functions is tightly coupled in the same business layer. It's tightly coupled. So I am using this shipping. This shipping module is using the code which is being used in the account section. I'm calling the functions which are being written in the account section. So these are tightly coupled here. But that has a lot of disadvantages, and that is why we need to go about microservices architecture. And in this case, we are splitting our business logic, which was tightly coupled. Now we have loosely coupled. So we are making this autonomous and specialized, so that these any two business logic are not dependent. I'm not calling the functions, whatever the code I'm writing for the account section, I'm not calling that particular code in any other module, shipping module. Suppose if account section goes down, it will not impact my shipping, inventory, or payments module. But whereas in the case of monolithic architecture, if any of my module goes down, suppose accounts module, one of the business functions or one of the functions got failed, it's not working properly, and if I'm using the same function everywhere, right, my all my application components will be impacted. My entire application will be down, but not in the case of microservices because these are independent, and it has a lot of advantages. We can use any different technologies. Suppose this is microservices 1, microservices 2, microservices 3. This microservices can be developed in Java language. This other microservices we can use Python or Node.js, any other different technology we can use it, or .NET, any other technology, any different technology we can also use it in the case of microservices, but not in the case of monolithic. We have to use the same language, the one we started with. Suppose we started with our .NET, so we have C#, so we have to use the same technology for our future scopes as well. There is no freedom, but not in the case of microservices. We are free to choose the technology as per the my requirement, or which best suits that particular module. So that is how we talked about monolithic and microservices architecture. I have got a question here. Is microservices a separate server? No, microservices is a sub application. Not you're thinking in a different Rekha. So microservices is a sub application. If I have accounts, shipping, payments, and inventory, like as one application here, I'm calling this for sub application as one application. But here I'm splitting the application: accounts, shipping, and payments, and inventory. So microservices is my one function, dedicated, specialized function. uh, it's the same. And if I combine, suppose if I have 4 microservices, 1 2 3 4, for my different business applications, right, if I combine these 4 microservices, that will comprise my application, right? So you need to think in that business logic terms. So we are just talking about business layer here. We are not talking about your web, your user interface, like your web server or DB server. No, those are same. I'm just talking about the business logic layer. Okay, sure, that is fine. Yeah. So that's how we need to think about microservices. Okay. Uh, just the business logic, specialized business logic. Thank you. Yeah. Okay, so let's talk about the containers. So we have this next question: where do this container run? Where do these microservices run? Right now we have splitting. So as per my last slide, we have now split my business logic, business layer into microservices. But the next question comes: where do these microservices run? So these microservices can run in VM, in physical server, right, and in VMs as well, but best it runs in containers. So where we are splitting up, right, we started with our physical servers, we went to our then virtual servers, right, VMs, and then we talked about containers. So our microservices run in these containers here because it's for the dedicated purpose. We are, because containers help us to use the unutilized space, right? That's how we are making progress in this IT world. We want to use all my like I don't want my resource to be unutilized, right? That is how we are talking about virtualization, and that is, and the next step is the containerization, right? Yeah. So where the next question is, where do these microservices run? So they run in containers. Okay. So that's what this we talked about, these containers here. So this is, I'm just doing a difference here between the VM and the container here. Okay. So this is my VM. This is my VM A, virtual machine A, virtual machine B, virtual machine C, and uh, and this VMs virtualize at the hardware level. You can see this. So we have different operating system. Guest, suppose this is my In VM A, I'm deploying application server. In VM B, I'm deploying my web server. In VM C, I'm deploying my database server. So I need different operating system, right? You guys must be using different operating system, mostly Linux flavor or Red Hat, mostly, right? Or any other. But in the case of containers, right? Now I'm talking about one particular VM here, okay? I'm now splitting up. I'm using one Docker engine. That's called container engine. Docker is the container engine. On top of my guest OS, this is my guest OS, host OS. Okay. Now I'm talking about one particular VM here. So on top of my host OS, I will just install my container engine. Suppose Docker. Most popular container engine is Docker. I install that, and then I can virtualize at the OS level. In the form of in the container, I virtualize at the host operating system level. Now you can notice I can deploy my application server here, my web server here in this container B, and I can deploy my database in the container C. And if you notice, I don't have operating systems here dedicated. I will use the binary and library of the host operating system in the form of containers, and that is why I don't need more of a space to deploy my application components. And that is how I am trying to reduce my like unutilized space. And here now I don't have this operating system dependency also. I can just use the host operating system and deploy my containers. uh, uh, in like in few like last session I demonstrated that in the demo I did few one demo. I demonstrated that even we can do that in our regular sessions. So that is how we create containers: container A, container B, container C. And the point to notice is that in the case of VM, we use separate guest operating system, but in the form of in the case of containers, I have just one host operating system, and my containers are virtualizing at the OS level, and they are using the binaries and libraries of the host operating system. I would need one operating system, but whatever the common binaries and libraries are, that will be used. I can have one, like suppose if my this is my Fedora or Red Hat operating system. If and for my application server also, I am using the same operating system, Red Hat. If I install that, suppose this guy has taken 2 GB of space, but there are a lot of common binaries and libraries, right? So I will be using the same binaries and libraries for my application server, and this particular operating system I would just need few MBs, maybe 200 MBs I can manage my application server with, because I'm using the same binaries and libraries of the host operating system. And that is how container works. It boots up in seconds, very lightweight. It boots up in seconds and takes fractions
Roshan,
of disk and memory.
hello Roshan, one quick question. So
Sure.
let's say this app B is no, it's an payment gateway, let's say, and here app C I'm using for database. How
Okay.
can we communicate? Can we communicate from app B to app C on the
Right. We
same
can
host
do that
base?
in the form of REST API. Yeah, we can do that. Communication is possible. Only point I mentioned that I want to make my code independent. I don't want like I'm talking. See, don't get confused. When I say microservices, I'm not talking about between layers. I can definitely communicate like how I was communicating in monolithic development. The same way we will communicate. I talked about, okay, as per my last slide, I talked about monolithic and microservices. I just meant about business layer here, okay? The REST communication between your web server and DB server is the same. The communication does not change between the layers. When I say microservices, I am basically talking about the business layer, and I'm splitting the business layer into various components, sub applications, and I'm making this sub application independent, so that suppose if this is my accounts, payment and shipping inventory, and this is and I have deployed this in the monolithic way of development here. So basically what I'm doing, whatever the code I'm writing in the accounts, I am free to use the code, same function anywhere, shipping, payments, inventory, and I'm calling it anywhere. That is when, if something goes wrong with my account, if suppose my account is not performing well, there are huge chances that my other application components will be impacted because I'm using the same code. That's what I want to reduce. I want to solve this problem in the case of microservices. Now I have splitted this code in this particular business layer, and I make those accounts, shipping, payments, and inventory independent. I'm not calling the function which are being written for the shipping module. I'm not calling the function which is being written in the accounts module or payments module. I'm making this independent. If something goes wrong with my accounts, because I don't have any code dependency, this will be working as usual, and this will be communicating with my DB server or your front end server. So that is a different part. Okay. Yeah.
Okay, and each container will have a separate dedicated DB assigned to them.
No, each container will not have. There will be
Not
one container
containerization.
for the database,
For each
and all.
microservice, you will have a dedicated DB.
Not always. You can have. I'm just showing here that I'm communicating separately, but I have the same DB. I have the same DB. There will be one container for my database and all my microservices. Suppose in this diagram, I am showing that I am using a different DB. This is my non-SQL DB. This is my SQL DB. This is my some other time series DB. I'm showing in that respect. If I have different DBs, I would need to use that. I can use that also in different. But if I have the same database, right? So all my microservices will communicate to the same database. So basically, I'll have one container for the database. I will have one container for the web server, but I can have multiple containers for my business logic, different business logic.
Again, con here is maybe if I have a host operating system who having some 3 to 4 containers on it, and if host operating system is down, then I'm going to lose the functionalities performing by those 3 applications, right?
Yeah, that's when we talked about in the cloud. We talked about high availability. We basically deploy. We don't deploy our application in just one server. We basically deploy in different servers as well for high availability. If something goes down, something goes wrong with one of the servers, my other server will pick the request. And I don't also like we have concepts of regions and availability zones in cloud. I'll just show you. Yeah, I'm going to show you that we have different regions and AGs, we call it. So we don't deploy our application in one AG. We deploy in multiple AGs, multiple regions, multiple AZs, so that if something goes wrong with one of the AZs, my request will be picked by other servers. So that's what we talked about high availability concept.
Okay, thank you.
Yeah, sure. So, okay. So let me just show you once, just give you a glimpse of what I mentioned about AGs and region, because people are maybe new to this. So this is my AWS console. Okay. I'm just logging in here. Okay. And okay, on this right side, I have various regions here. So this is my US East region. This is my Mumbai. So this is my data centers where all my data centers are available. Basically, what I mean, I will not just deploy my application in one region. These are all my regions. Okay, US East, Ohio region, and US West. So the point is that I will not deploy my application in just one region. I will deploy my application in multiple regions. If something goes wrong with one of the regions, my request will be picked by other regions in the case of disaster recovery. And within the region, I have availability zone concept, AGs we call it, AZ. And basically this is the region, and one region will have multiple data centers, 2 to 3 data centers, one region. This Mumbai will have 3 data centers. So I will not host my application in one data center. I will host my application in multiple data centers as well. So if something goes wrong with one of the data centers, my request will be picked by other two data centers. So that's how we work in cloud. So
One
that is
one
how.
question. Let's say my application deployed on two data centers. Okay, and if
Yeah,
one data center one came down and data center two picked up. Okay,
yeah.
and maybe we fixed the problem in data center one and it be no and it is up and running. Then data center two will go in that case.
Not it will go down if we have set up the load balancer between these two data centers. It will be going on. If I've set up a load balancer between these two data centers, right? Because that is how it will be picked up. My load will be balanced.
One is for
And
disaster recovery, right? I mean, it's not the load
so
balancer. One
disaster
is for
recovery is
disaster.
between the regions. Between two regions, we talked about the disaster recovery. Uh, Suppose, just to answer a question, if my first one of the regions got fixed, right, then again the process is smooth. You will not even realize that how my region one came up and region two is just being in standalone phase. So the process is smooth here. Yeah. If we have configured one region to be used all the time, it will be always one region. If one region goes down, your other region will pick up the your request. Yeah. Okay. So let's. I hope I answered your question. Uh, okay. So that is how this work. Your VMs and containers. Basically, in just one VM, I can host multiple containers. And I just need to use Docker engine for that. And if I install container engine, and Docker is one of the popular container engines, and once I do that, I can deploy my application uh, in the form of containers, and it takes very less space. It has very lightweight. It boots up in seconds, and it takes fractions of disk and memory, right? And these are the advantages. We can, it's portability, resource efficiency. That is the main point here, resource efficiency. That's what I intend to do. From started with the physical server, my resource efficiency was not that great, right? It was a lot of unused resource space was like the case there. That's how I entered the phase. We entered the phase of virtualization. We talked about VMs, splitting the same physical server into multiple VMs, and then using that unutilized space, right? And that's how we talked about containers. So using that unutilized space even further, and even we have this container engine. By that, we can use the host operating system also. We don't need a separate guest operating system as in the case of VMs, right? So that's how this technology has been developing, and its speed, it boots up in seconds, and yeah, and that increases the speed. A lot of performance issues get resolved there, and scalability. We can suppose this is my container one, container two, container three. If my container one needs more resource, suppose this is my search functionality. Container one is my search functionality. I'm just talking about the business logic here, but just know that there will be containers for my web server and database servers as well, dedicated containers. I'm just talking about the business logic here. Suppose this is my search functionality, and the search functionality needs more resource because there are more users are accessing the search functionality. So I can dedicatedly scale my search functionality because I have split it. Now I will just give more resource to these containers, or I can make sure that this particular VM uh, has few of that, of having the containers of that particular type, so that that particular containers get more space, not the container which do not require more resources. But in the case of VMs, if I want to scale up, I have to provide for all my application component, even if they are not required, because it's tightly coupled, right? I cannot help it. I have to scale at the application server level. I cannot scale individually as per the functionality, but I can do that in the case of containers. So these are the advantages of that. And we have this Docker is the container engine, right? And we have Kubernetes, right? And when we have more containers, a lot of containers are there, and that is how we manage by using this orchestration engine, container orchestration engine, and this is one of the most popular container engine is Kubernetes, and that's to manage multiple containers. Yeah. Okay.
One question.
Sure.
Yeah, so you told, for example, the VM has multiple containers. So when we run some test like load test or endurance test, so you also told that if the memory or CPU, if the resources or if it need, it will be consuming from the other container, correct?
Right. Suppose I am doing everything at the VM level, right? Suppose
Right.
this is my VM and I have four containers or five containers.
Okay.
And if there are containers which do not require more of a resource, so they will not be taking up, but my other containers will be taking up more space. Yeah. Tell me. Yeah. Please.
Okay. So for example, we use PCF, so which is like Kubernetes, I believe.
Yeah.
So the containers, when we run the test, right, sometimes it go beyond 100% the CPU. So then we asked our PCF team, DevOps team, then they came up saying, okay, it is acceptable. It will try to take the resources from other containers when the other containers are not used. So if this is the situation, how can we evaluate whether, okay, this application is taking this much of CPU? For example, in regular kind of VMs, right, if it reaches 100, of course it will crash or whatever happens, but here it is going beyond 100, like 120, 130. As you said, it will take the resources from the other containers.
Okay. So yeah, good question, Naga. So I'll put this in perspective. So
Okay.
suppose there are five containers. This is one of my VM, and I have five containers or three containers. Okay. And uh, so there is nothing like I can split. There is nothing like I can split. Suppose I have four CPUs, four threads, four
Okay.
CPU. It is not like I can make this. I can locate for this particular container. Let's locate two threads, or let's locate two CPUs. I cannot do that way. Okay, that is not. So containers are nothing but the processes. Suppose if you're using your laptop, your Windows laptop, if suppose the operating system you are using is Windows, you have opened multiple applications like Word document and some browsers. So you cannot locate that. Let's Word document use only this much resource. You cannot do that, right?
Right. Right.
Same is the case with containers. Containers are nothing but the processes for the operating system.
Okay.
You cannot do that. Well, if your other containers are not being heavily used, so they will be using less space, okay, or
Okay.
this less resource, and that's what the other containers will pick up. And that's what you need to do testing. How many containers you can host in one VM? That is the point of testing, because that depends on your application, how heavy your application is, how is your architecture is being done, what is your application, that you're going to test and find out that how many such containers you can host in that particular VM, so that you get a better performance, or you don't have any problem. That you need to find out that out, and you have to do
Okay.
proper testing of that. Yeah.
Yeah. Yeah. Okay. Got it. Got it. So one more question. So these
Okay.
containers, for example, nowadays everything is in cloud, right? So, for example, let's take Azure. Um, so is the PCF or this Kubernetes is hosted on top of the VMs in Azure, correct? Is that correct statement?
There are multiple ways you can host your Kubernetes. In Kubernetes, we have something called AKS. We call it Azure Kubernetes Service.
Okay.
And in the case of AWS, we have EKS, something. Okay. Let
Yeah.
me just show you. We have one functionality called, I was about to show you these things. We have something called EKS. Okay. Elastic Kubernetes Service. So this is my AWS console here. Similarly, in the Azure, you have AKS, Azure Kubernetes Service. So
Yeah.
obviously in the backend servers will be used. But now if I talk about EKS or AKS, these are the managed services. You don't need to worry about the underlying hardware. You are just thinking about the number of pods or containers running and what all application you want to host in that particular pod. uh, because these are the elastic, these are the managed services. But if you want to install Kubernetes separately, you can do that. You can provision your instances here, and then on these instances you can deploy your Kubernetes separately using Kubedium. You can do that way. So it depends on you what you want to, how you want to use it.
Okay. Okay. Got it. Yeah.
but
Thank you.
but in the underlying hardware, your servers will be used. There is no other way. But if it is managed, basically you are not bothered about the underlying hardware. They will take care. Suppose EKS, if I'm using EKS, my Amazon guys will take care of the underlying hardware. I am just thinking about the containers and pods.
Hmm.
Okay.
So is pods also called as containers, or both are different?
No,
Or
no, in the Kubernetes world, we call pods. We don't call containers. And one pod can, 99% of the case, one pod will host one container. 1% of the case, one pod can host multiple containers as well. And when I have multiple containers in the pod, one container will be helping my other containers. But 99% of the case, one pod will have only one container. In the Kubernetes world, we call it pods. We don't call it containers. Yeah.
okay, but end of the day, VMs has pods and pods has containers.
Container. Yes, you're right.
Okay. Okay. Got it. Thank you.
Sure. Okay. So
Correct.
let's.
So, quick question. Quick question before you move on.
I
So, I'm
intend to take the
assuming all
questions
of the.
at the end of the course. Okay, please come again. Yeah.
No, go ahead. Go ahead. We can
Yeah,
circle
you
back
can
later
post
on
your
this.
questions. You can post your questions.
Continue to another question.
Okay.
When it reaches to 100% of the CPU, when container reaches to 100% of the CPU, can we make it another container in runtime? Can we make it available as the
Exactly.
another
You have
container?
we have auto scaling concept in Kubernetes. There is something called auto scaling.
Yeah.
Horizontal auto scaling, HPA we call it, horizontal pod auto scaler. So and cluster auto scaler as well. So we have those concepts. If the requirement is of more pod, more containers, this will be automatically scaled up. And you can also provide that this particular pod, if it is taking more than this much percentage, create one more pod. Or if the number, if you have exhausted the number of pods in one VM, so it will create one more VM, and on top of that you will have more pods. So that is what this auto scaler thing does, and it is the feature of in Kubernetes. HPA we call it, horizontal pod scaler, and cluster or auto scaler. We have these features. Yeah.
Okay, got it. Thank you.
Sure. So let me finish this, then we can take up the questions in detail. Yeah, sure. Thank you. Okay, so let's come to we started with, just to brief everyone, that we started with this particular diagram here. We touched base with DevOps. We did look into microservices. We did look into containers. Now we are in the last phase of the cloud here. Okay, so that is how it is. Okay, cloud. So this is my on-prem infrastructure. That is how it was. If I'm not talking about, okay, is this class primary lecture or technical demonstration? No, this is a just demo of our course. This cloud performance engineering and DevOps. This is just a demo that how we're gonna cover, what all we're gonna cover. I'm gonna talk now, browse you through with the course content. So that is, I'm just highlighting the few of the topics that we're gonna cover in detail. Yeah, thank you, Adley. Okay, so let's talk about this cloud now. So we started with this, we have this on-prem infrastructure here, okay, where we have this data center, networking, storage, servers, virtualization, operating system, databases, security, and applications. They are all my components, and if I'm doing this in the on-prem, I'm owning all the things here, all the hardware, software, everything here, all the operating, I'm owning everything here. How it is different in cloud? in cloud, I don't need to create a data center. I need in the case of on-prem, this is the legacy IT. This I'm talking about is on-prem here. If I'm using on-prem, I need to create land, I need to set up a building, then I need to purchase all the hardware resources, and then all the operating system. I need to manage everything. I need to put security guard, cooling. A lot of money is being spent if I'm putting everything on-prem on my data center. That is where this cloud comes and help a lot of companies. If a company cannot afford to put these many initial setup, the cost of it, they can go with these cloud offerings. And we have three options there: infrastructure as a service, platform as a service, and software as a service. In the infrastructure as a service, but like first of all, in all these services, I don't need to purchase my land. I don't need to set up my data center. I don't need to purchase the land. I don't need to construct a building. I don't need to purchase any hardware. What I'm purchasing here, data center, networking, I'm not purchasing anything here. But I'm gonna leverage everything of the cloud provider. Suppose let's talk about AWS or Azure or Google Cloud. I can use the data center or the hardware of my Azure or Amazon guys to host my application. When I'm saying infrastructure as a service, basically this is the thing owned by the cloud provider. Your data center, networking, storage, server, virtualization, this will be owned by the cloud provider. I'll be responsible as a customer in the infrastructure as a service. I'll be responsible only for maintaining of these components: operating system, databases, security, and applications. In the case of platform as a service, these many things will be taken care by the cloud provider. Any Azure or Amazon or Google. I'll be responsible as a customer. I'll be responsible only for my application in the platform as a service, because in the platform as a service, we basically as a developer, right? We basically develop our application and all the underlying hardware, your runtime environment, your operating system, everything will be managed by the cloud provider. I am not thinking about all these things. I am just thinking about developing my application. Even the runtime environment will be provided by the cloud provider. In the software as a service, I am not thinking about anything. I am just using my software like Google, Gmail, your YouTube. These are the software as a service. Somewhere it's being hosted, somewhere it's being done. I am just using the as a service. I am not thinking about anything. Your what's where it is, your video, where it is located, your Gmail, where your mailbox, what's the database, what's the operating system of the database. I'm not bothered how it is configured, in what all regions it's configured. We are not bothered. We just type gmail.com and it comes up, right? So that is the software as a service example. So in this cloud, we have these three options. Either I can choose software as a service, platform as a service, or infrastructure as a service. And it's a big relief for the any startups, right? Because if they don't have the initial setup or initial amount of cost, if they don't want to put the initial thing, right, they can go for these cloud providers. And that is why nowadays people are in most of the companies, they are going from on-prem to the cloud, because they don't have to it's not like about purchasing, it's about maintaining as well. When you own hardware, you need to invest a lot in cooling, because they generate a lot of heat, your servers, right? You can just take an example. If you have any particular gadget like AC, it also creates heat, right? So just think of big servers. If you have it will huge amount setup required for maintenance and setup. That is where this cloud comes into picture. Rescue of those players, they want to deploy their application, they want to build one application, but they don't have the initial setup, so they can go with these cloud providers. And they can either go with infrastructure service, platform service, or software service. They can use it. Yeah. And we have different service models just mentioned, and deployment models also: hybrid cloud, public cloud, community cloud, and private cloud. So if I want to public cloud is our normal example. like your Amazon and all those things. They are called public cloud, where in one data center, all the companies, all the customers can come and they can leverage the hardware. Right. In the private cloud, basically I am owning the complete data center. In the private cloud, in the hybrid cloud, basically I have my database on-prem. I don't want to go take my database to the cloud provider. I don't want to do that. So you can have also this setup. You can have database on-prem, but you can have other components in the cloud. That's the hybrid cloud example. In the community cloud, like banking, all the banking companies, right? They can club together, they can join and they can make a group, and then they can purchase complete data center. They can own a complete data center. So no other customer can come in and they can leverage the hardware. Only these bank people can only come and use. They own the complete hardware of that particular data center. So that's called the community cloud example. Okay. So that's all about this particular thing. I just started with, just to brief everyone. So we started with DevOps, microservices, containers, and cloud. And the important point, the key takeaway point is that how these guys fits in. In the DevOps, we started with waterfall, agile DevOps, microservices, monolithic. Now we are talking about microservices, how it is different. Then monolithic, that's important to understand. Containers, we are not just talking about containers. It is not something which has come new. We are just splitting up the VM and we are calling it containers, right? And cloud, that is how it is, the importance of cloud. Okay, so that was the brief about those 4 topics. And we're going to cover now course syllabus. This particular demo is for. So we're going to cover these many things. We're going to cover cloud computing. In AWS, we'll be taking AWS and we're going to demonstrate. We're going to make you comfortable in AWS cloud. As you have noticed that I have an account and I was about to demonstrate something. Yeah, I'll be doing that. So we'll be going over AWS and this Linux command line. I would like, because go in detail, because to work in container, Kubernetes, all these things, if you want to be comfortable in working with Kubernetes, Docker, and containers, right? We always communicate using Linux command line. It's not like Windows, right? So we want to get comfortable with Linux as you're comfortable with Windows. So we're going to cover this in detail, Linux command line in detail of all the I have a slide to demonstrate all the content of the Linux command line, what all we're going to cover. Then we'll look into software application architectures, mostly monolithic and microservices here. And when we looked into Docker, this container engine, we'll go in detail how we create containers and how do we manage everything. Then we're going to talk about Kubernetes. And we have taken EKS. Mostly I am discussing EKS, Elastic Kubernetes Service, and normal Kubernetes as well, in both ways. Then we're going to talk about performance engineering and DevOps, how performance engineering fits in DevOps, and then CI/CD pipeline using Jenkins. Yeah, Adley, I'll come to that. So this course is like 35 hours. So yeah, it is a very huge course. Yeah, it takes time. Yeah, 35 to 40 hours. Okay, so let's go one by one. When I say AWS, I'm going to cover these many things. We're going to cover these many things. We'll make you comfortable with cloud. First of all, you need to understand what is this cloud, basic terminologies, what is cloud computing, right? Different models, what is the service models, infrastructure as a service, platform as a service, software as a service, what are these deployment models, right? We just talked briefly about this, but we're going to cover in detail. And we're going to create our AWS account, right? And then we're going to talk about all the services, a lot of services like security. We'll talk about IAM. We understand what is this AWS region and what is this AGs. We're going to talk about in detail about how do we create EC2 instance, how do we provision EC2 instance, and what is this private, public, and elastic IP? What is this? And we're gonna connect remotely. So everything will be hands-on. Okay, it's not just theory. Everything will be hands-on. We're gonna cover storage services. There are storage services called uh, EBS, EFS, and S3. We're going to talk about VPC, serverless offering. We have Lambda API gateway. We have simple notification service, SNS we call it. We're going to talk about cloud formation, Beanstalk, and most important for the performance engineer is the elastic load balancing and auto scaling group. We want your resource to be auto scaled, right? And load balanced, right? Both the things we want to set up. So that's one of the very important topics. And we're going to talk about cloud computing using AWS CloudWatch, and we have CloudWatch X-rays, AWS X-ray as well, and we have also CloudWatch Container Insights to monitor the containers. Just AWS? No, we're gonna cover everything in detail. And yes, we're going to talk about everything like with respect to performance. Yes. So to go about performance, right? First of all, we need to also understand. We need to be comfortable with what is this cloud is all about, what is the services is all about, and then we can talk about performance point of view, because this AWS is the most popular one. If your application is being developed using Lambda or API gateway, first you need to understand this. What is this API gateway or Lambda? And then we're going to talk about how you can leverage this in the point of performance, what all you need to monitor. And this elastic load balancing and auto scaling group, it comes to that. And for the monitoring part, we have AWS CloudWatch. Training time, as I mentioned, like 35 hours. Yeah. So let me go over this cloud console once. Okay.
Hello.
Yeah.
Yeah, I have a question. So,
Yeah, please.
there is a course for AWS DevOps also, right? So, what is the difference between that course and this course?
No,
Because
this is
AWS DevOps,
this is the same course.
AWS DevOps.
No, this is the cloud performance engineering in DevOps. The course name is that. See,
Okay.
why it is the same course that we are talking about here.
Mm-hmm. Then,
We're talking about the same.
but it does have performance engineering with DevOps, right?
Right. We're talking about the same course. If you would have noticed Isha Training's website, I'm talking about the
Mm-hmm.
same course here.
Okay.
And
And what is AWS DevOps course? Does it has any difference?
yeah, DevOps, we're gonna cover in DevOps, and we're gonna talk about CI/CD pipeline. I'm gonna cover that. I'm gonna come to that. Let me complete that. I'm gonna come to that.
No, I'm still confused. Means this course is performance engineering with AWS Cloud, right?
Yes, in
Yeah.
DevOps, we're gonna
And
use.
in DevOps. So
Yeah.
there is also another course for AWS DevOps, right? So what is the difference? Means I can do AWS DevOps also, which will cover more of CI/CD pipeline thing, or you are going to cover that content, that topics also into this course, which will
Where
be
is that?
equivalent.
First of all, where is that course? May I know? Since you have mentioned about that.
I have seen I think so there was some DevOps course also, right? AWS
In,
DevOps
with Isa or some.
with
No,
some
with
other,
Isha.
not with Isha.
Yeah,
Yeah.
even I
So
have seen.
If
okay.
you say
So
with Isha only, means if other trainings are also providing AWS DevOps.
no,
So I
it
just
was
wanted to make sure.
basically I'm dealing with performance engineering here. How we
Mhm.
gonna talk about performance point
Yeah,
of view?
I'm
Yeah.
looking for performance engineering only, but I just wanted to make sure that this will complete my AWS with AWS DevOps topics also.
Yes, we're gonna cover AWS DevOps. I'm gonna cover that in my. I was having this in the next slide, the content of
Uh-huh.
DevOps. I'm gonna cover
Okay.
that.
Okay. Thank you.
Just bear with me for some time. You will understand more
Okay. Okay.
visibility about this particular course. Yeah,
Okay. Good. Thank you.
sure. Thank you. So yeah, I just started with one of the topics here, AWS here, and I was about to demonstrate that we're gonna cover everything hands-on. We all will create this AWS account. We'll have this, and we're gonna practice here. We're gonna first create our EC2 instances. We'll start with that. We're gonna talk about VPC. What is virtual public cloud? What is VPC? The networking point of it. What is security group? What is NACL? Access security list, NACL. So we're gonna talk about all the things here. So we're gonna talk about Kubernetes, EKS, VPC, X-ray, so cloud formation. So these are the services here. We cannot cover entire thing. It's an ocean. But we're gonna take things which is very important and relevant to our performance engineering point of view. So AWS gateway, if I talk about the storage services, so what is EBS, what is EFS, what is this S3? So if I talk about compute, so EC2, Lambda, Beanstalk, what is this? And then and on this management point of view, CloudWatch, what is this CloudWatch? This auto scaling, cloud formation. So we're gonna cover very important services from the performance point of view. It's not possible to cover entire AWS. No one can do that. It's an ocean of information. You would need 2 years to complete the entire services. So, but we're gonna cover what is important for our performance point of view. What is this different storage services, and someone mentioned about what this code commit this code deploy code pipeline. So if I talk about AWS, right, DevOps, these things come into picture. What is this code pipeline, code deploy? So these are the AWS services for the DevOps, but we're gonna cover with Jenkins. Just to answer the question here, we're gonna cover with Jenkins as well, and we're gonna see what all these services do. But we're gonna cover in Jenkins, the most popular continuous integration tool. We're gonna talk about VPC in detail. First of all, we need to get our basics straight. First of all, we need to understand how do we set up networking in AWS, right? What is this CloudFront? What is this Route 53? What is this API gateway? We need to understand these things first, to then we can delve into the performance engineering point of view. Yeah.
Okay,
So
that's great. So, quick question for you. So the classes is what? Is it 5 days a week, and how many hours per day?
Okay, it will be around 1 to 1.5 hours, mostly 1 hour 15 minutes daily. Yes, and we are doing it 5 days a week. But once the batch is set up, we can talk to everyone and we can come to a conclusion which all days and what's the timing of it. But mostly it will be like in the morning, IST time, 7:15 or 7 o'clock in the morning in the IST time. But if people are interested to attend in weekdays, in weekends also, so we can also mix up 3 days in weekdays and 2 days in weekends. Again, it all depends on the people joining. But yeah.
Correct. So you said 40 hours. So does the course go on for 4 weeks?
4 weeks around, yes, 4 to 5 weeks. Yes, you're right.
Okay. All right.
Yeah. Okay, so that's the one of the topics about the AWS. So we're gonna cover, and everything will be hands-on. Okay, if I mention EKS, we're gonna set up our own cluster in the Kubernetes, and we're gonna demonstrate everything. Okay, so everything is hands-on here. So if you notice, I have an like EC2 instance here. We're gonna connect to the EC2 instance, and we're gonna demonstrate everything. If you notice, if I have one AWS EC2 instance here, so we're gonna connect to this EC2 instance, and we're gonna like just giving an example that yeah, everything is hands-on here. So let me connect to this particular.
One question.
Yeah. Yes.
Let's say I'm having 2 containers running on a machine, and I want to monitor how much each container is actually getting utilized with respect to CPU or memory. Any other tools available to do that?
We have Docker stats to do that. Tools side, we have CloudWatch. do that. So we
Not
have a
with
lot of
respect to cloud, not with respect to cloud, but if it is on premise.
Yeah, just type docker stats, one of the command line option, docker stats. You can do that. Okay. Yeah, I'll come to that. Okay. Let me complete this first. And then I'll take up questions in detail. Yeah. Okay. So that's about the AWS here. Yeah. I was demonstrating this. I can connect to the EC2 instance. Let me just connect here. Okay. Just this is my public IP. Let me just okay. Demo. Yeah, I have demo instance here. Okay. Yeah. Right. So just now I connected to my instance here, and we're gonna do everything hands-on. Everything is hands-on here in this topic. Yeah. So this is the same IP here. You can just see this is my private IP. I'm connected to the same private IP here. Yeah. Okay. So let me complete this. Then I'll take up questions. Okay. So that's about the AWS first part, cloud computing part. Second topic is our Linux command line. It's very indispensable to get a master's in this command line, Linux command line, because whatever we work on, right, either we work on container or Kubernetes, anything what we work on, we mostly work in the Linux operating system, right? So we need to get comfortable working in Linux, how we are comfortable in Windows, right? If we want to open a directory in Windows, we know we just need to take our mouse to that directory and double click, it will open. Well, if you want to open a file, we can do a notepad, right? We can create a notepad and we can write and save it. But if I want to do the same thing, if I want to delete the data in Windows, I can do that. But if you want to do the same thing in Linux, how to achieve that? How to do that? If I want to look at the processes, if I want to look at the system information, if I want to look at the hardware information, if I want to look at the performance monitoring and statistics, if I want to look at what all users groups we have in Linux, what is the file that if I want to open a file, if I want to navigate in through different location, how to do that, how to look at the number of processes, file permissions, can I access this, can this user access this particular file, does that user has the right permissions, networking, right, how to look at the IP addresses, how to archive a file, how to create a zip file. We know in Windows we can do a right click and we can zip it, but how to do that in Linux? How do we install packages? What type of Linux flavor it has? It is a Debian flavor or is it a CentOS? How to install the softwares, right? How to do SSH logins? How to search a pattern in Notepad in Windows, right? We can do a Control F and we can search for a word. But how to do that in Linux command line? Is there a way? Can we find a word? Can we replace a word? Can we do the same thing in Linux? What we can do easily in Windows? So we need to master this command line. So that's the second thing we're gonna cover. We're gonna cover the Linux command line in detail. As you would have noticed, we're gonna cover everything in this. Everything will be hands-on here. So we have this EC2 instance. We're gonna demonstrate. This is one of the Linux Ubuntu flavor. Okay. So if I want to look at what is this thing is, so I can get to know. So this is the system information, right? I can get to see everything. I can do if I want to do how much is the resource being utilized. I can do a top of it. I can do a lot of stuff as I can do in Windows, right? If I want to search for a file, if I want to look at the directory, how to do that? Okay, so there are so many. If I want to go to this folder, how to do that, right? So we're gonna demonstrate everything in real time. So everything is like hands-on here. Do we have the right permission? If I want to access this, if this user, Ubuntu user, want to access this can or execute any particular shell script, can we do that, right? And yeah, and will be followed, it will be followed by the most important is the self scripting. We're going to do the self scripting here. While doing the performance, right? If you don't have any commercial tools, right? So we can do a self scripting. We're going to learn self scripting as well. Then if I want to keep monitoring my resources using mpstat, we have a lot of commands. mpstat free, we have mpstat, we have a lot of commands we have, and this all provides you. I need to install systat. So what is this systat? Unless I don't install systat, I cannot use mpstat. There are a lot of things we need to know about working with Linux. So we can also learn about shell scripting, how to do shell scripting, Unix shell scripting. Because if you're doing a load test, right, suppose for 1 hour, and if I want to keep monitoring the memory for 1 hour, by issuing this command, I can get to see that, okay, so I am this much memory is being used. But if I want to document, if I want to keep like if I want all my data point for the 1 hour duration, how to do that, right? So for that we need to do a shell scripting, and then we need to keep pushing this information to a file, and then at end of the test, I should have all my data points, so that if I draw a graph, I can get to see what is my usage of my memory or CPU, right? I can do that. So we'll also look into shell scripting. That's the important point. After learning all the commands, we're going to talk about shell scripting. So that's the second thing we're going to cover. Third thing we're going to cover in detail about the software application architecture. Mostly what is this monolithic way of development, and how we do work with microservices architecture, right? So we're going to cover that. And then we talk about container engine, Docker, right? Docker is the most popular container engine. How do we create containers, right? What is this what is this Docker hub, right? What are the advantages? So whatever I just discussed, it was just a glimpse. We're going to cover in detail everything. What is this Docker hub? How do we push your image? What is this image? How do we create image? We have Docker, something called Docker images, right? How do we create image? We're going to create using, we're going to install Docker Compose, and we're going to create our Docker image by, we can create our own Docker image, customized Docker image. How to pull image from Docker Hub, how to push your image from the Docker Hub to Docker Hub, right? And how do we run it? So and everything is through Linux command line. So that is what I intend to cover in the last slide, that we would like to get everything like comfortable. We want to be comfortable with Linux command line. That's where I can do much well in these topics, either it's Docker or Kubernetes or CI/CD pipeline, whatever, right? Okay, I'm gonna take up the questions at the very end. Okay, so we're gonna cover everything here. Like as you can mention, build Docker using Docker file. What is this Docker file? What is this Docker volume? How to install Docker Compose, and how to build and run images using Docker Compose YAML file, and how to create. We will talk about this YAML file as well in detail, and how do we build application, right? Yeah. Then we talk about Kubernetes a lot in detail. Kubernetes, what is this container orchestration engine? What are these features of COE? And why do we need Kubernetes? So everything is from scratch. Everything is from at zero level. You don't need to know anything about anything. So we're going to cover everything from scratch. What is this pod? What is this EKS? What is this ECS? We have this services in AWS. We call it Elastic Container Service and Elastic Kubernetes Service. What is the difference between ECS and EKS? How do we set up EKS cluster? What is pod? Pod deployment, multi-container, pod networking. what is pod, how do this pod communicate, right? And we talk about the pod lifecycle and services. What is this node, port, cluster, IP, and load balancer? What is the importance of these things? What is this horizontal pod autoscaler? What is this cluster autoscaler? How do we achieve that? If you need more pods, suppose your pods is being exhausted, your load is increasing and increasing, and your whatever the pod you set up initially is exhausted, can your application scale up automatically? Will your pods will it get created automatically, auto scaled? We're going to talk about, and in what all ways we can do auto scaling. Can I if in one cluster one of the VMs got exhausted with pods, can I create one more cluster? Can we achieve that? How to achieve that? So that's the cluster auto scaler for you. So all these things are related to performance, right? Auto scaling part, pods, and in general, first of all, we'll take about the VMs, load balancer, and auto scaling group, and then we talk about this Kubernetes as well. And we're going to talk about performance engineering in DevOps, so this is not a DevOps course, okay? This is not a DevOps course. This is dedicated to performance engineering point of view. Someone asked me how is this course DevOps. So we're gonna not talk about, this is not a DevOps course. We're gonna not talk about all the phases here. In the DevOps, we have life cycle, right? We have continuous development, we have continuous testing, we have continuous integration, we have continuous deployment, we have continuous monitoring. Yeah, we're gonna talk about continuous testing. That's where our performance testing comes, and we'll talk about how do we create jobs there, Jmeter jobs, right? We're going to talk about continuous monitoring, where we're going to talk about your AWS, how do we monitor, right, your performance test. And then we talk about integration, because in Jenkins only we have to create jobs, right? In the Jenkins, how do we create performance jobs? So all the topics, we're going to talk about deployment. We are not going to talk about deployment, what all tools are there. We're going to not talk about continuous development, what all tools are there. It's not a DevOps course. DevOps course, they will talk more about everything here, but we're going to focus our attention here to this performance for continuous testing here. Okay, how do we create?
So are you going to include LoadRunner, Jmeter into
Jmeter.
this?
I'm going to demonstrate Jmeter. Yes. So this is what I was talking here. I'm going to create this pipeline. Okay. This is the last topic, continuous performance testing in DevOps. This is what I'm going to cover in DevOps. This all things I'm going to cover. I'm going to cover, first of all, what is this continuous integration? What is this Jenkins? How do we work with this Jenkins? And we're gonna install, so whatever we're gonna do in cloud. Okay, we're gonna do everything in the cloud, no on-prem. It's a cloud course. Everything will be cloud course. How do we install Jenkins in the cloud, right? And how do we integrate Jenkins with DevOps tools like Git and Docker Hub? So whatever required for a performance engineer, we're gonna cover everything. What is the CI/CD pipeline? And we're going to talk about these Jmeter jobs. We're going to create a Jmeter job. So this is one of the screenshots I have taken from one of my courses, and we are building this kind of pipeline, and we're gonna see, we're gonna do testing one by if this particular phase fails, right? This particular job fails, it will not be going forward to the Jmeter job. It will not trigger the Jmeter job because it has failed. So, and if Jmeter job is successful based on our criteria, right, then only your code will be pushed to production. So we're gonna see everything in real time. We're gonna create CI/CD pipeline. We're gonna create jobs. We're gonna set up some conditions for the Jmeter job, and we're gonna also get automated feedback, email notifications, how to set up that. If your test is successful or if your test failed, Can you get automated email notification? Can you do that? So we can also look into those parts. Creating pipeline and scheduling the jobs, pipeline jobs with dependencies. And then we're going to talk about introduction to AWS services. If I talk about AWS services in the CI/CD pipeline, what all the AWS services which can do this work? Like we talked about Jenkins, right? So we have similarly in AWS services we have code pipeline. So we're gonna look into that as well, how it relates to AWS. So all our courses is in the cloud, yeah, and that's what you're gonna learn by the end of this course. You can read about it, and I have put this sincerely that that's what you're going to learn here. If you attend this course, that's what you're going to learn. You're going to, first of all, if someone is new to the cloud, right, cloud world, they're going to first understand what does this cloud mean. First of all, I have observed that people do not understand exactly what the cloud actually is, because they are not in this on-prem and cloud thing. So first we're going to start from very basics. What are these core cloud concepts? We're gonna first lay the foundation first of all, and you're gonna learn about all the AWS cloud computing and its various services from the performance engineer's point of view. Yes, we can cover KU. Yeah, we are covering. We can cover. And strong foundation for your cloud learning journey. If you want to go ahead after attending this course, you can very much like go for the certifications. You just need to cover some more aspects. I can guide you that, because I have done some certifications. So you can also go over this cloud practitioner and solution architect associate certifications after attending this, because we're going to cover around 20 to 25 AWS services. Just to name a few: IAM, EC2, Lambda. I just told you, right? CloudWatch, SNS, ELB, it's Elastic Load Balancer. ASG is your auto scaling group. EKS is Kubernetes service. VPC is networking. So this VPC is very important to understand. How do we communicate, networking, how this works. And we can also learn about architecting resilient, highly available, and fault-tolerant cloud solutions. How to do that? How can we make our cloud solution secure, highly available, resilient? We're going to also look into, so we'll start from basics and then we'll ramp up on that. As I mentioned, we're going to cover a lot about Linux environment and command line, because as from a performance point of view, we spend most of our time in Linux environment, right? We don't work in Windows as much as we are working in Linux environment. Most of the time, because all our servers are deployed in Linux, we need to go inside the Linux box and we need to troubleshoot, right? We are always doing that. So we're going to cover that. Talk about this architecture, right? Monolithic and microservice architecture. This Docker technology, container technology, Docker engine, and Kubernetes. And we have this CloudWatch. We are covering this monitoring point of view in the AWS console. CloudWatch. We can also cover this CloudWatch container insights. This is for the container monitoring, for the EKS or all the containers. And we're going to cover the DevOps course and then CI/CD pipeline. So this is the thing in highlighted mode. All the topics are covered from very scratch. So very scratch. So we are starting from very basics. Even if you are new to these things, because we do understand that since all the companies are started to migrate from on-prem to cloud, right? People would not be aware of this cloud technology. So we are starting from very scratch. Even if you know things, you may like it, because we're covering from very scratch, and then we are ramping up as whatever we require as from the performance point of view. Yeah, I'm free to take up the questions now. Yeah.
Yeah, the questions are already sent in the chat.
Okay.
Can you?
Okay. Okay.
Roshan, related to Docker and Kubernetes.
Yeah, please.
Yeah, Roshan, related to Docker and Kubernetes.
Yeah. Tell me. Yeah.
whether we also cover this performance. This one, say for WebLogic, we do also have some key performance configurations, like that for like Docker and Kubernetes, like those performance parameters will also be covered, or
Yeah, see, for the monitoring part, first of all, we're gonna start with how to set up Kubernetes, like Docker. So first of all, we need to install Docker. Then how do we create containers? And then how do we monitor the performance, the statistics of it, and what can we do to make it better, right? So,
yeah,
and how to test, how to go about testing your VMs, right? Suppose your application is deployed in Dockerized environment. How to go about testing it? How to go about troubleshooting it? So we're going to cover everything in detail. So first of all, we need to understand how do we implement this, how do we monitor this,
okay,
and if we have issues, how do we fix that? How to move ahead? What all could be the performance test cases that we need to cover while setting up the Kubernetes environment for your organization? And if you're having these many issues, these issues, what all to cover? What all to look into? So everything, yeah. Okay, same like availability zone and availability set of Azure. So we have something called region and availability zone
fine, okay.
concept.
The
Yeah,
most
hello.
frequently functions
Yeah, please come
specific
again.
to Docker and Kubernetes. I'm asking. That,
Yeah,
in specific to Docker and Kubernetes, I'm asking.
yeah. I'm not able to
Okay.
understand your question. Can you? I just answered your question. Oh, any other information you're looking for, especially?
No, that's it.
Okay, okay. Thank you.
I just want to know, like, no, just this one. I just want to know, like, say, in a case like, say, we have like a memory exception, like we used to like take up and heap dump, and say we used to monitor this JVM and DC logs, and like that. In cases like what are the most common performance issues may occur as part of like Docker and Kubernetes, apart from this resources level. So as
We
per a
have
pure
Docker
this
logs.
one, the
If you have set up your environment in Docker, you get Docker logs, right? Suppose as you mentioned
hmm,
about taking heap dump or thread dump, right? Basically, you're talking about logs,
yeah,
right? So we in the Docker world, we have something called Docker logs. We need to look into Docker logs to identify
okay,
what type of issue you're having. Yeah, we'll look into all those things. Yes.
Hey, Roshan,
okay,
I
fine.
typed something. Roshan, I typed something on the chat. That
Yeah, yeah,
is, I'm just reading that out. So, can we
yeah.
monitor containers and visualize in Grafana or any other dashboards? Yeah,
Yes.
I know you told about the Docker stats, but I'm just looking for a solution to do live monitoring in Grafana. Yeah.
Yes, we can do that. We have CloudWatch Container Insights. Okay, let me just show you.
No, not with the cloud, with on-prem. On-prem.
On-prem, yeah, you can set up Prometheus and Grafana you can set up, but we are covering as part of cloud here.
No,
We are
I'm
doing.
specifically looking for one of the container that is running on my machine, and I want to visualize that in any other dashboard utilities like Grafana.
Yeah, you can set up Prometheus and Grafana. You can do setup, but our course we are dealing with cloud here. But I can definitely guide you how to go about doing that in on-prem. Uh, you need to set up Prometheus and Grafana. For that, you can visualize all your container information in Grafana, and you can set up Prometheus. Yeah, I can definitely guide you on that. Yeah,
Okay, okay, thank you.
yeah, yeah. Any other question? If I'm missing out, please can you spell out for me? Like no, not Kafka. No. Oh, could you able to AWS itself is a very huge topic. We're covering 20 to 25 services. We are going in detail about AWS. But having said this, if you know one of the cloud services, right, cloud providers, it's easy to relate with other cloud providers as well, like Azure or Google Cloud. So it's very easy to do that. Once you understand, okay, so these things are there in one of the cloud providers, because all the cloud providers implementation, they are on the same level. They implement similarly. So we are covering about AWS in detail. That's what our intention is. There's no point in covering half. So we are covering AWS in detail. Yeah. Useful for people compared AWS cloud practitioner. Yeah, this will be useful because we're talking about architecting as well. We're talking about two certifications here. Cloud practitioner is the basic certification, but we are also talking about solutions architect associate certification. You can also do that because the topics which we're gonna cover VPC in detail. We're gonna cover architecting in detail. What is this Bayesian host? What is this private subnet? What is the public subnet? What do we deploy in public subnet? What do we deploy in private subnet? We're gonna cover all these things. How do we architect in cloud? How do we monitor in Kubernetes? So we're gonna cover all these things in detail. What is this Lambda? What is this API gateway? What is this X-ray? So these things are not uh, not as the part of cloud practitioner. You need to go in detail, in depth to go for the solution architect associate certification as well. So we're gonna cover that as well. Yeah. Okay. So can we complete? Yeah, we can. We are covering. So 4 to 5 weeks we need. Yeah, 5. Yeah, we are doing that. Yeah, max to max 6 weeks it will go.
Like version,
Yeah,
like we will take an application which is like an which is like built on like Microsoft architecture, and it will be demonstrated and
yes,
this
I'll
one
be
in
demonstrating.
AWS
Yes,
cloud, and that's slow.
yes, I will be
Okay, we will
demonstrating.
have an real-time application.
Yes, real-time
Okay.
application. Yes, I'm gonna demonstrate. I'm gonna build application. I'm gonna do services, building API gateway using API gateway. I'm gonna build APIs, and I'm gonna demonstrate that how do we monitor in AWS cloud, CloudWatch container insights. I'm gonna demonstrate everything. Yeah.
Okay.
No, this course is for the cloud. This dedicated for the cloud. We're not covering on-prem. Yeah. But what do we actually need here? Okay, the same question, the Grafana and all. Yeah, I can definitely guide you. How do you set up Prometheus and Grafana in cloud, in on-prem? Yeah.
Okay, I mean the InfluxDB, what I'm looking for. InfluxDB in Prometheus. Can I do that?
See, either you use Prometheus or InfluxDB. Both are time series.
Okay. In that case, I want a InfluxDB container to be visualized in a dashboard. What is your solution for that?
I see. I have only worked on Prometheus. Like so when we talk about containers, right? When I talk about containers, Prometheus is the preferred time series database which are being used in the
Great. I
industry.
mean, for me, I cannot change that influx to other time series database. Only InfluxDB I want to visualize in a dashboard. Any solution from your?
See, you can do that. That you can. We also do that. I'm not. If you don't talk about the containers. See, if I talk about the containers, microservices, then Prometheus is preferred.
Oh,
If you
okay.
want to look
Other than
at Jmeter,
Prometheus, okay. Other than Prometheus, I mean, I just want to monitor InfluxDB container. That's it. Other than Prometheus, do you? I mean,
oh, you just want to monitor InfluxDB container.
yes. And
And
I'm not finding any option in the Grafana. Maybe I'm wrong. So
okay, I'm not sure what you're exactly looking for here, uh, but yeah, I have not done that. Whatever you're asking, I have not done that way. I have used Prometheus to monitor containers and used Grafana for the dashboard. Yeah.
the
Uh,
straight question in Grafana, can we monitor InfluxDB container?
Grafana InfluxDB container. I have not done that way. I have used containers, monitor containers in Prometheus. I have not done InfluxDB container. That's what I'm telling you. That I have
Okay.
not done that way. Yeah. I have not created in InfluxDB as the form of container. I have used as the time series database only. I have not created as in the form of container InfluxDB. That's what I told you. Yeah.
Okay, got it.
What are the challenges, risks in cloud computing? So setup. The first initial setup is very important. You need to understand the setup is very important. So cloud computing and on-prem, it is not different. Okay, it is just the case. On-prem, we are owning all the resources. We have the data centers. We are owning all the infrastructure, right? That's the on-prem for you. But if I talk about cloud, I'm leveraging. I am owning the hardware, and you're asking me, can I use your hardware? I am AWS. So I'm telling you, yes, you can use my hardware, you can use my resources, but you will have to pay something. So that is where it is. The implementation, the technology is not different. Only thing is that how do we set up? What all the services? How will you use my resources? In what all way you're gonna use my resources? That is important here. Yeah. The setup is very important. Understanding is very important. Rest, everything is same. What all you are doing in on-prem, you're gonna do the same thing in cloud. That's not gonna change. Training time, yeah. Training time, as I mentioned, right? It will be like 1 hour 15 minutes daily, 1 to 1.5 hours. We'll end the topic to a conclusion, to a logical ending. So we may extend for some days, a day or two. We may go 1.5 hours. We may go 1 hour 20 minutes. We may go 1 hour 10 minutes. Again, it depends on the topic, and we're gonna end the topic to a logical conclusion. So yeah, and it will be like between 1 and 1.5 hours like on weekdays. That's what I'm gonna plan, Monday to Friday. But if it is too much, we can take few days breaks in between. Like Monday, people are not feeling comfortable to get up early in the morning, or so we can have that on weekends as well. We can mix both, 3 days in weekdays and then 2 days in weekends. Again, when the batch starts, we can discuss that part. Yeah, but it will be like 4 to 5 days a week for sure. Yeah.
Roshan, are you going to send us the PPT as well for the discussed topics?
We're gonna cover yes. So whatever topics I'm gonna cover, yes. If you see, I have this particular this is how I share everything. Whatever I'm gonna discuss, all my material, this is shell script, this is the YAML files, right? All the YAML files plus autoscaler, all these we discussed in Kubernetes. Whatever we're gonna discuss, right? I'm gonna share everything using this cloud drive. I'm gonna add you guys here, these names. So yeah, you'll be given access. Yeah, everything. Your PPTs, your
okay.
YAML files, everything. Yeah.
Okay, fine. Thank you.
We have a lot of PPTs to cover. Yeah. So, okay. So length of the course, yeah, same, like 35 hours. It may extend to 40 hours as well. Yeah. And if you want some other topics also in detail, if you come up with some more questions, some more topics, we can also do that. So what is the course certification track of AWS administrator? Okay, we're gonna discuss that some other time. Yeah. So, but for any AWS certification, we need to get the basics straight. We need to understand what is this cloud and all those things. So, okay. So I think I have covered all my questions, all the questions here. Yeah.
You did. So thank you very much.
Yeah. Thank you, everyone. Yeah. Thank you.
Yeah, thank you, Roshan.